Hello, everyone. My name is Muhammad El-Tabak. I am Associate Professor in the Computer Science Department, and I am also the Graduate Coordinator of the Data Science program. And today in this session, I will go with you over uh, some information about the BSMS in general at WVI, and then why BSMS in specific in data science. What are the benefits? What is this mechanism? What it entails? And how you get the best benefit from BSMS. So let's get started. So first, what is the BSMS program, or we can call it mechanism at WBI? So it is a program or mechanism that is very unique and very specific to WBI undergraduate students. It's a very huge amount of benefits included in this program. And it does not apply to any other students, nationwide or international students who apply for the master degree at WBI. So it's very unique, very specific to our undergrad students. And that's why if you are considering or thinking about graduate studies, master degree, and maybe later on in the future, PhD as well, then definitely keep BSMS program in mind and try to get the benefits that I will describe today. So BSMS, basically, you will get 2 degrees. You will get your bachelor degree and you will get master degree in less amount of time and with less amount of effort. And when I say less amount of time, automatically it translates to less amount of money as well, because time is money. And we will go over the details how you can do so. But the BSMS for data science, one key factor is it is open to all majors at WPI. That's something that does not apply to some departments at WPI. I know there are some departments where the BSMS program is only specific to the students in that department, but that's not the case for data science. Data science is open for all majors, whether you are in different engineering majors, bioinformatics, biology, chemistry, physics, it applies to all majors. And the reason is we know that data science is actually deeply integrated in all aspects of our lives and all applications. So it is deeply integrated in all of these disciplines that I just mentioned. And definitely you will need data science skills to manage your data, to extract knowledge from the data, to interpret the data, and so on. And that's why we designed the data science program, the master degree specifically, to fit all majors. And that I will focus on some details as we move forward. Then BSMS, you will get these 2 degrees, bachelor degree and master degree, usually without any benefits, without BSMS. Bachelor degree by itself is 4 years. Then master degree, separate degree as master, is 2 years. So total for these 2 will be 6 years. But with the BSMS, you will get the benefit that you can do it in less amount of time. Typically, you can do it in 5 years. And I would say 5 years is a conservative side. I saw several students who can actually do the BSMS and they get their master in 4.5 years, or even with careful planning for their courses and so on, they can even get it in 4 years. So how it can be done, how you can save 1 year or year and a half. So basically the key trick is double counting of courses. And that's what I will go over in detail as we move forward. Double counting, what it means, you will take some courses, either undergraduate 4,000 level courses or graduate courses. So there are certain courses you will take, and these courses will double count. They will give you units toward your bachelor degree, and they will also give you credits toward your master degree. And here, when we talk about double counting, it is actually the limit is 40%, 40% of your master degree. So in data science, the master degree is 30 credits. So if you count 40%, that will be 12 credits. So that's a huge amount of credits. And it, again, transfer to saving time. That's why you can save 1 year or even more than 1 year. And it will also transfer to saving money. In WBI, one credit, one graduate credit, I would say it's around 1500. I don't have the exact number on top of my head, but I would say it's around 1500. That's per credit. So multiply 1500 by 12, right? That's a huge amount of money. That's around $18,000. That's a huge amount of money that you will save. So definitely it's a win-win situation. Saving time, saving money, and getting the 2 degrees. So again, I am stressing on the point that BSMS is not really a single degree, is not combined degree. You will get 2 separate degrees. You will get your bachelor in whatever major you are in, and you will get master degree in data science. And that's why you have to satisfy all the requirements for the 2 degrees, for the bachelor and for the master degree. So now let's move to why data science. So now let's say you are convinced that BSMS is the right program for you to do master degree, but now why you choose data science over other programs or disciplines? So first I will go over some technical aspects. Then I will give you some insights for long-term career. Why you choose or why should you choose data science? So first, we know that data is actually all around us. All applications around us is actually managed by and driven by data. It's very hard to think about any application around us that is not centered around data. You name it, think about sustainability, like water, energy, air pollution, all types of businesses, healthcare and medicine, our interaction, social media interaction. It's all digital, it's all data. Traffic, smart cities, shopping experience. All of these are now centered by or centered around data. All of these applications are generating huge amounts of data that if managed in the right way and the correct way, it's really impacting our lives in all aspects and it's improving our lives. So that's why it is deeply integrated in all applications and all science disciplines. Now, all of these applications are collecting data. So we have huge amounts of data. The cycle for managing these data is very complex. And that's why we need data scientists, skilled data scientists. So this cycle of managing the data starts with data collection. How to collect the data in the first place. And you name it, think about your domain or your application. You will see these challenges I will mention right now apply to your domain. So data collection, how to collect the data. Then how to store the data, how to clean it, how to organize the data and index the data so you can query the data in quickly and more efficiently. And going all the way to how to apply data mining, machine learning techniques, how to apply neural networks on your data, statistical analysis in your data. Why? Because you would like to get insight and you would like to get knowledge from the data. And then this insight and knowledge will feed back to your application so you can take decisions and take actions. So managing this cycle, complex cycle of data, definitely needs skills. And that's why we have the data science program for master and PhD to prepare our graduate students with these skills. So that's the technical aspect. But now let's talk about the long-term career. Why you should consider your career as data scientist. So one of the reasons is data science is one of the fast growing market. So it is estimated by 2026, the coming 5 years, that there will be around 12 million jobs in data science. They need data scientists. And that's not only in the IT domain, it's in all domains, because I mentioned hospitals need data scientists, insurance companies need data scientists. News companies need data scientists. Retail stores and retail websites, they need data scientists to manage their data and extract knowledge from the data. All domains need data scientists. So it is a fast growing job market. And we know that probably in US, most universities now offer a data science program, right? Most universities offer master degree in data science. Yet the number of positions and the demand on data scientists is much bigger than the supply. And because the demand is much bigger than the supply, it's easier to secure a good job and the pay will be higher. So that's why data scientists usually receive a high pay. This number, again, from the two sources I am including in the bottom of this page or this slide, you can go to these two sources and you will get more information and more statistics. But that's on average, around 115, 116K per year. So that's on average high compared to many other disciplines. And data scientists, because they play an important role in whatever company they are in, whatever industry they are in, usually they are in good position or high position in the company. That's another reason. Versatility and applicability to countless applications. So if you have the data science skills, regardless of your interest, whether your interest in biology or chemistry or in physics or in healthcare or some other domain, you will find data science challenges and the requirements in whatever area you are interested in. And that's why it is versatile. It's easy to find a job that matches your interest and your skills. One important thing is it is also continuously evolving. Usually, when you graduate and you go to the job market and you start working, one key thing that is very nice to have is you are continuously building up on your background and you are continuously learning more and more. And that's something inherent in the data science discipline. Data science, it's continuously evolving. Every year, there are new technology and the new systems and new applications that you will need to learn. So you will keep learning more and more and building your career. So these are few points I wanted to highlight why probably you should consider data science compared to other domains. So now going back, so let's say why you should consider a master degree in data science. As we mentioned, that's probably summarizing few points. Now you will get the 2 degrees. Getting the 2 degrees is something prestigious. You graduate with a master degree. Definitely it's more valuable compared to graduating with just a bachelor degree. Think about how many students graduate with a bachelor degree. That's a large pool of students. But how many of them graduate with a master degree? That's definitely much smaller pool of students. So having the master degree is a prestigious thing that will help you in your long-term career. Then the second thing is why you should consider master degree, because the technology, right now we know that the technology used in industry, in different companies and different sectors is actually complex technology. So usually in your bachelor degree, you cover the core technology or the core courses that definitely will give you important background, but this important background probably is not yet makes you ready for the technology outside. There is still a gap. And that's why doing master degree, you will learn more technology. You will learn advanced technology. So you will be more prepared for the challenges in the market and the different companies. And then you will complement your bachelor degree, whatever field you are in, with the data science skills. And I have one slide specifically how this works. Like, let's say you are from biology or chemistry, how data science skills will complement your degree. So I have one slide for this one, but that's, as we mentioned, you will get the data science skills, build these on top of whatever major you are in. Again, master degree will give you competitive edge when you apply for jobs or seek employment. Having master degree means you are more educated and you have more courses and you learn advanced technology compared to bachelor students. And that will give you a competitive edge. Some employments and some companies and the industry are interested not in data scientists, but at a certain level, let's say advanced level, or data scientists with certain level of experience, right? So that's something you may not achieve with only a bachelor degree. But if you have master degree, then you will have this experience. On the long term, definitely master degree will give you credentials for leadership and management role. If it's not immediate when you start your job, then it will be fast track. Then you can move forward to more advanced positions. And finally, that's what we highlighted before, you will get a higher pay compared to bachelor degree. How much? Again, on average, master degree gets higher pay compared to bachelor degree with around 10 to 15K. So multiply this one by the number of years you will be working. That's significant amount of money. So now I hope I give you the main idea about BSMS and the key advantages you should keep in mind. But again, let's say now you are convinced you will do master degree. I see some students, or I have seen some students stop by my office and then they say, what about the other approach? What about I start working with my bachelor degree, then after maybe 2, 3, 4 years, I will go back to school to finish my master degree, right? So that's the first approach. You rush to work, assuming you already have an offer and good offer, then you will come back after 2, 3 years to do your master. How this one compare with doing BSMS, right? What are the advantage and disadvantage? I am not saying one is always better than the other. It definitely differs from one to one and it's case by case basis. But what I am trying to do here is to highlight the benefits and advantage and disadvantage of the two approaches. So let's go with the first approach. You will immediately rush to work after your bachelor degree, and your plan is to go back after a few years. So one big advantage is you will gain industry experience. You will work in real world problems. You will see these real world problems, what your company is facing, what technology they are using. So when you go back to school after a few years, then you will carry this experience with you, right? So you will have the insight of what real world problems are out there, what technology they are using, what are the challenges they are facing, right? So this experience is very valuable that you can carry with you in your master degree. Also, another big advantage is sometimes you can get the company pay for your master degree. So that's a huge benefit. You will not be paying for the master from out of your pocket. The company is paying for you. But keep in mind, that's for the entire master degree, which is 2 years with all credits of master. There is no reduction in credits. So these are good advantages. But what is the drawback? What is the disadvantage? There are few to keep in mind. The first one is it is definitely harder to get a degree and go back to school and start studying again while you are working. We all know that work right now is highly demanding. So it will require from you at least 40 hours per week. So 40 hours per week. Add to this that you would like to study and finish your master degree. So the maximum you can do is to be part-time student, and usually will take around one course per semester. So if you do so, it's hard to do it. Let's face it, that's one of the facts. But it will also take much, much longer time to finish your master degree. So when I said master degree can be done in 2 years, right? That's for full-time students taking 3 courses per semester and spending 40 hours on these courses. But when you do it as part-time and taking 1 course per semester, then it will take probably 3 or 4 years to finish. So again, that's a disadvantage with this approach. And if you go with this direction, then let's do the count. Now you started working as bachelor degree, and probably you will take 2 or 3 years, then you will go back to school. So you will do 3 years first, then you will take 3 more years to finish your master. So now you have spent 6 years until you get your master degree. These 6 years you are going with the less salary because you started as bachelor degree student, right? Now let's switch to the other one. The other one is the BSMS, where you spend more time in advance to finish your master, then you go for work. So the benefits is all what I covered before, and I will not repeat this again. You will be saving time, you will be saving huge amount of money, you will be getting the double counts of credits. All of these are the benefits. But what are the drawbacks? Well, there are also some drawbacks. The first one is you will be paying for these extra credits, like the remaining 60% of your degree, you will be paying for these from your own bucket. That's one thing. Second, it will hold you off the job market for 1 year or probably 6 months. So definitely these are some of the drawbacks. But if when you consider once you graduate, you will get higher pay and you will move forward faster in your job and so on, probably these disadvantages are much less significant compared to the other approach. So now thinking about WVI Data Science, I would like to highlight few unique characteristics or unique features in the data science program at WVI. The first thing is it's interdisciplinary program. What it means is it is truly an umbrella. It is a program on top of 3 main departments. The first one is computer science. The second is the math and the statistics department. And the third one is the School of Business. So data science is designed to include these 3 departments. And basically what you will get is you will get the computational skills. You will learn the CS skills like data mining, machine learning, databases, deep learning, all of these techniques that are in the computing side, data science, CS department, you will learn all of these. Plus, you will learn also the statistical and mathematical background and techniques and tools that you need for data science. And you will also learn the business side, the business intelligence, and how to interpret the results to fit your business and how to make sense of these results and the actions you will take to benefit your business. So that's the business intelligence aspect. And our data science faculty are actually coming from the 3 departments. So you will be taking courses from CS, math, business, plus courses that is designed specifically for data science. So because as I mentioned before, data science is continuously evolving field and fast evolving field, we keep updating our program. So it's right now it's well established. Now we are in the 7th year, but we keep updating our courses and introducing the new courses. So we have always special topic courses like some of these courses about, let's say, IR, information retrieval, or deep learning, and so on. So special topics courses plus other courses that you will see are cutting edge courses. like big data management for distributed systems, Hadoop, Spark, NoSQL databases, uh, AI courses, machine learning, deep learning, reinforcement learning. All of these courses, many of them are designed specifically for the data science program. One key feature and unique characteristic that is actually, I see it as differentiating factor comparing our data science with any other data science program in other schools is the capstone project. We have a capstone project before graduation. So in order to graduate, one of the two options is to do this capstone project. It's called GQB. This project is 100% industry driven project. So basically, we have a partnership with many companies, and the logos you see here are just a subset of the companies we have partnership with. And you will see it's from different domains and so on. And these companies will provide us with real world projects and real world problems that they are facing and they would like to solve. All of them involve data science challenges. So we have these projects, we have mentors from the company, and you will also have mentor from the data science program, faculty member from data science program. Then it will, the faculty members or the mentors from WVI will form teams. So it's a team-based project. Now you will be working on one of these projects from the industry sponsored projects. And many cases, the outcome from these projects actually will be integrated back into the production of the company. So it's a very good experience. Most of our students enjoy this experience. Yet to say, in addition to the technicalities, also it's building relationship. So you will be building relationships and connections with industry, and that definitely will help you to secure a job later on. What else to highlight about WVI data science? So I would like to highlight these 2 points. The first one, in data science, it's not all about just taking courses, the typical courses, but you will also have research opportunities. You will be able to interact closely, one-to-one interaction with our faculty and do some research. That can be independent study course, directed research course, or you can be even doing thesis. That's more intense research. So different ways to do research with our faculty, like independent study or directed research. You will register with a specific faculty, and you will be involved in one of the research projects, and you will get credits toward your master. The last thing is internship. Internship is something that is very valuable, and we encourage almost all our students to do internship. So you will be working in a company in some data science role and getting some data science skills, and you will get paid by the company, plus you will get credits for your master degree. So it's a win-win situation, and that's why we encourage our students to always do internships. So now, given all of this introduction, now hopefully you are convinced about the benefits and the importance of master degree and the BSMS. Now let's go into some technical details. I will start first with the master degree requirements. What are the requirements for data science master degree? So the master degree is 30 credits. So usually our graduate students, our graduate courses, each course will give you 3 credits. So 30 credits basically translates to 10 courses. You need to take 10 graduate courses or equivalent to that. So how these courses or how these credits will be divided? There are some requirements. First, I am highlighting here 5 core areas. We call these boxes or each of these areas as a core area, and we have 5 core areas. and the students have to take at least one course in each of these core areas. So one of them is mathematical analytics, one is called the data management, data analytics and mining, and then the last one, business intelligence, and all of these on top of another core area, which is called integrative data science. At least you need 3 credits in each of these core areas. And you see the mix between the core areas, like some of them are to build math skills, math and statistics skills, some of them to build computational skills from CS, and the last one to build some skills from the School of Business or business side. So counting these, that's 15 credits. Then we have 2 tracks to finish your master degree. One track is called the GQB, which is the capstone project I just highlighted in the previous slide. That's called the GQB, and it is equivalent to 1 course. So that's a graduate qualifying project. Or the other way, you will not do GQB and you will do thesis. And the thesis will require more extensive research with one-to-one faculty and possibly having publication by your graduation time. And that's equivalent to 3 courses. So it's 9 credits. Usually 90% or probably 90+% of our students who will do master degree will go with the GQB route. And that's most BSMS students will go the GQB route. Usually those who will decide I will do thesis, they are interested later on in doing a PhD. So that's why getting exposed early to do research, that will be a good idea. So that's the capstone. You will choose one of these 2. Most students go with the GQB. Then what's left for the credits is basically will be electives. So if you do the math, let's say you are doing GQB, now you collected at least 18 credits, core plus GQB, then what's left to finish the 30 credits are 12 credits, like 4 courses. So these will be elective courses. And we have large pool of courses that you can select from based on your interest. So that's the structure of the master degree in data science. Now I would like to zoom in into some of these blocks just to give you some idea what's inside these blocks. So we have this course chart that basically I would like to highlight few points. Let's forget about the specific names and specific course numbers. It's tiny and I am not expecting you to read these details. But what I would like to highlight is the following. Let's focus on the red boxes. You see we have here 5 red boxes, 4 vertical ones, and this horizontal one. These red boxes are the core areas I just mentioned in the previous slide. And under each core area, there are many courses, and you are required to take at least 1 course. So at least 1 course from each of these core areas plus this one. Most of our students actually tend to take the majority of courses from the core areas, from these red boxes. So these are the core areas. Then the blue box, these are the set of elective courses. These are the pre-approved elective courses. And you can see it's a large number of courses coming from different disciplines and different programs and departments at WVI. All of these you select from them based on your interest. One more thing to highlight in this slide is the top 2 courses, the 2 courses we have here on top. Actually, these 2 courses like DS 517 and CS 5007, these 2 belong to the electives. So any student is free to take these 2 courses as electives. They will count toward your degree. They will give you 3 credits each and so on. However, what I would like to highlight is these courses are designed specifically to build the background if you are missing certain background. For example, DS 517, if you are, let's say, you don't have a statistical background. So you do programming very well, but you don't have any statistical background. Then you should take this transition course to build this background, which is designed specifically to give you this background. Then you can move forward with the advanced courses. The other side is if you have no knowledge or previous experience with programming. Let's say you are from chemistry or biology and you didn't do any programming before. Then you take this transition course. It will give you the credits, plus it will build the programming skills for you so you can take more advanced courses. So going back, how the data science can complement your major and give you more skills, that's something I will highlight quickly here. So let's say you are from wet lab sciences. Let's say biology, chemistry, physics. So when you do BSMS or get the master degree in data science, basically you will build your computational skills like data management, AI, machine learning, data mining. You will build all of these skills, and you will also build the mathematical skills, how to do statistical models, how to do dimensionality reduction, and so on. And if you are from the theory domain, let's say you have bachelor degree in computational theory or pure statistics, then again, data science will give you the computational skills, plus it will give you the business intelligence side, the business side of how to interpret the results, how to do storytelling, how to put your theory and your models into practice, and so on. Finally, if you are from the computational side, let's say CS or data science, then you will also build more of mathematical skills or mathematical analytics and the business side. So now before we move on and focus on the double counting, how to do the double counting, how to get the benefit, let's learn about these two units. Undergraduates in WVI work with units, but graduate courses work with credits. So how these two converge to each other, like units and credits, how they map to each other, that's something we need to go over before we move forward. So usually, one undergraduate course will give you 1/3 of a unit, and that's equivalent to 2 graduate credits. So 1/3 of a unit, which is undergrad course, will give you 2 graduate credits. And keep in mind that usually our courses, our graduate courses, are 3 graduate credits. So here you will get only 2 graduate credits. If you would like to do something extra, let's say you will do 1/6 of extra unit, let's say independent study, that usually will translate to 1 graduate credit. So doing a typical undergrad course plus some extra effort, let's say independent study 1/6, then you will get half a unit for your undergrad, and that's equivalent to 3 graduate credits, which is a typical course in our graduate courses. So now let's talk about double counting. That's the mechanism to get the benefits of BSMS. So how many credits you can double count? It's up to 40%. And definitely, if you are doing BSMS, definitely we advise you to get the full benefit, which is double counting 12 credits. So how to get these 12 credits? There are 2 ways. One way is to take 4,000 level courses that will count for your bachelor degree and will also count for your master degree. So there are certain lists. There is a list of which 4,000 level courses are already pre-approved. And if you take from this list, then you will get the undergraduate units for your bachelor, and you will get graduate credits for your master. So in order to see this list for the 4,000 level courses, that's in the graduate catalog. So you need to go to the graduate catalog, go for the data science chapter or section, and then you will need to scroll few pages until you reach BSMS section. Under the BSMS section, you will find this list of the pre-approved 4,000 level courses that you can take from. That's one way. The other way is you will take graduate courses while you are still undergrad, but you will take some of the graduate courses from data science, like that big chart that I showed you a few slides back. You will take any of these graduate courses. So definitely it will, or automatically it will count toward your master, but it can also count toward your bachelor degree. And that's something you need to confirm with your department. So regarding the 4,000 level courses, as I mentioned, to get the list, go to the graduate catalog and you will see the pre-approved list. That's the list you should select from to get these double counts. So as we mentioned before, 4,000 level course is an undergraduate course. And if you don't do anything extra, then it will double count and will give you 2 graduate credits. Because we mentioned undergrad course automatically will give you 2 graduate credits. And all the pre-approved courses, you don't need to do anything in advance or before taking the course. If you take the course and you get at least grade B, like B or A, then automatically it can count toward your BSMS and you will just need to list it in your degree. So what if you are interested in getting the full 3 graduate credits? Then before you start or at the beginning of your class, let's say in a given 4,000 level course, talk to the instructor and tell the instructor, I am interested in doing BSMS and I am planning to take this course and double count it toward my BSMS. And I would like to get the 3 graduate credits. So I would like to do something extra to get the extra 1 graduate credit. Usually, instructors most of the time are flexible and they will provide a way for you to do this extra work. Usually it is an independent study. So it can be at the end of the course, you will do some extra project or reading a research paper and presenting this paper to the professor. But definitely there is a way that you will do some extra work over your undergrad requirements and you will get the 1 extra 1/6 unit, which is 1 graduate credit, plus the 2, so that will be the full 3 credits. So one advice that you should probably keep in mind while selecting which courses to take is always keep in mind that you must fulfill these core areas. You must take at least 1 course in each. So while you are doing the double counting, a good thing is to do the double counting and also satisfy the requirements of some of these core areas, right? So if you take 4,000 level course that has graduate course matching with this area, then you will satisfy this area. Then if you do 4,000 level course, let's say for machine learning, and there is an equivalent graduate course under this area, then you will also satisfy this area. So you are getting the double counts of credits plus satisfying some core areas. So that's something you should keep in mind. So one question that usually I get from students, which is, let's say I will do a 4,000 level course, and let's say it's a database. So database 4,000 level course, and there is a graduate equivalent course here, but I didn't do the extra work. So what I get is only 2 graduate credits because I just did the course, undergraduate course. So I get just 2 graduate credits. Will that still satisfy the core area, or I need to do 1 extra, 1 credit more of work? So the answer is If you take the 4,000 level course and it has a matching course here for in a certain area, it doesn't matter whether you take it for 2 credits or three credits, it doesn't matter. As long as you took the 4,000 level course, then you satisfy the core area. So you can take it for 2 credits and then still also satisfy the core requirement. So now the other option or the other alternative is you will take graduate courses. And again, you will see the course chart for data science that I presented before. Any graduate course in this list will automatically count for the master degree, but you need to make sure and you need to check with your department that this course will also give you units for your bachelor degree. And if you are taking graduate course, keep in mind it is semester long, but it will give you half unit for your bachelor degree. Okay. Again, one thing to keep in mind, and that's something that already also exists in the graduate catalog, we have some of our 4,000 level courses highly overlapping with equivalent graduate courses. So you like 4,000 level in database is highly overlapping and 80% content matching with the graduate level course. And we have a list of these courses, which 4,000 level is matching or equivalent to which graduate course. So the benefit of this table is you cannot take the undergrad course and the equivalent graduate course and get both counted toward your degree. It's one of them. So definitely when you choose and you select which courses to take one of the two. Don't take the undergrad and the equivalent grad because it doesn't make sense. So now that's for double counting from the list of pre-approved courses. So are there other courses you can take and get the double count and it's not pre-approved? The short answer is yes, there are, but you need to get first approval from the department. So you cannot just take the course assuming it will double count, then apply for this course and maybe the data science program may reject the course. So if you have such course, let's say it is independent study, directed research, or something outside the list of pre-approved courses, before you take the course and assume it will double count, before you do so, communicate with the data science program. Communicate with the graduate coordinator, which happens to be me this year, but it may change next year, and so on. So communicate with the data science program, double check if this course can be counted and it can be approved or it cannot. So that's basically the requirements. So now we covered the double counting mechanism, which courses you should take to get the double counts. You should aim for the 12 credits, right? And now you can translate 12 credits will be how many courses? If you do 4,000 level courses and you only get 2 credits for each, then you need 6 courses. If you do the extra work for each one and you will get 1 extra credit, then 4 courses will give you the 12 double counted credits. Now, how and when to apply? So usually I encourage students to apply during their junior year or very latest early in the senior year. Why? Because you need to have time to plan your courses and to select which courses will double count to get the benefits. If you are 1 semester left, right, or 1 term left in your undergrad, then you decided I would like to do BSMS, you may not have enough time to collect the 12 double counted credits, right? So you will not get the full benefits. So give yourself enough time to plan which courses you will take and will give you the double counted 12 credits. When to how to submit your application? That's the online application. Go for the WVI online application for master degree. And you will submit the application like any other student. The key difference is you have to make sure there is a field or flag in the application says BSMS applicant. Make sure you check this flag. That's the flag that will say you are BSMS student, and you will get or applicable, all the benefits we mentioned are applicable to you. As WVI undergraduate student, you will also get some benefits. So the application fee is waived because you are WVI undergrad student. So we waive the application fee. That's around probably $70, $75. And also there is no requirements for you to take extra exams like TOEFL, GRE exams, and so on. There is no such requirements. Very, very important point that you should keep in mind, which is you should submit your application and you should get approved or admitted for the BSMS program before you finish your major. If you graduated with your major and then 1 month or few weeks later you decided I would like to do master, you are no longer eligible for BSMS. BSMS is only for students while you are still in your bachelor degree. So make sure you will do the submission, you will get approved and admitted before your graduation time. Okay, so what we look for when you submit your application, how to make your application or increase the chances of your application being admitted and being approved. So what we are looking for is basically some signs to show that you can do the work for the master level, the graduate courses, and you can do this level of work. So we are looking for high GPA. That's one factor. If you have taken some courses at the 4,000 level course, 4,000 level, maybe 1 or 2 courses, and you did well in these courses, or maybe one graduate course, and you did well, that's definitely a good indication that you have the skills and you have the capabilities to do well in the graduate courses and your master degree. So that's something we look for, at least having one course, 4,000 level or grad course with a good grade. Again, if you are applying for the data science, probably by now you can get the idea that data science degree is technically a deep degree. There are CS courses, there is a lot of programming, there is a lot of courses, again, that requires math and the statistics skills. So having some of this background is definitely a plus. So if you have applied and you have some programming skills or you have some stats skills, try to highlight these skills in your application, maybe in the personal statement, because this definitely is a big plus. Plus, definitely positive recommendation letters from faculty. It does not have to be data science faculty. Any WVI faculty or even external mentors or supervisors from somewhere else, as long as it's positive and it's a good recommendation letters highlighting your technical skills and so on, that's what we look for. So now everything went well, you submitted your application, you are admitted, then what's next? Then the next step is you will be assigned an advisor. You will be assigned a data science faculty advisor, and usually this will be the graduate coordinator. And you and the graduate coordinator should communicate and finalize your plan of study. So what courses have you taken so far? How many courses you double counted? What will be the remaining courses to finish, maybe let's say in 1 extra year or 1 extra semester. So you need to finalize your plan of study. So that's mostly the content I wanted to highlight and share with you today. What's left is I will go over a use case. I will give you some scenario, and we will walk through this scenario just to apply all what I mentioned over this use case. So let's imagine we have a senior student from computer science. Because I am from computer science, so I am familiar with the CS courses. So let's say we have this senior student, and that's what the student has in the senior year. So now the student has taken these 4,000 level courses. So the student took database systems 2, that's one of the 4,000 level courses. And the student also communicated with the instructor, that's one of the pre-approved courses. So automatically you will get 2 graduate credits as double count. But the student communicated with the instructor and they did some extra work. So in this case, the student will get the extra credit. So that's what you see here, 3 credits. And it will also give you half unit for your bachelor degree. That's a double count. Then the student also took machine learning, again, 4,000 level course, and didn't do any extra work. So what you will get is only 2 graduate credits. And you will get the 1/3 unit for your bachelor degree. The third one is visualization. The visualization course, and you did some independent study or some extra work. So you will get the 3 credits, the full 3 credits. Again, double count, and you will get half unit for your bachelor degree. So these are 4,000 level courses. Now, the student has also taken a data mining course, which is graduate course. So in addition to this, the student took data mining course, which is a graduate course. So this one will give you 3 graduate credits because it is graduate course, and will also double count toward your major that will give you half unit. So all the red credits I am highlighting here, these are double counted. But this student went beyond the double count and also took one more course, which is not for double counting, but it will only count for your master degree, which is Introduction to Data Science. So that's one of the core areas. So that will give you 3 credits toward your master, but it's not double counted. So no undergrad courses, right? So now let's see the status of this student right now. So basically, by finishing the senior year, now this student has collected 14 master credits. So if you count all of these red and the green, these are 14 master credits that the student has collected just by when finishing the bachelor degree. Among these 14, 11 of them are double counted, which are the red ones, right? So the red ones are double counted. So 11 double counted credits, 3 more for master specifically, that's 14 credits. So how many core areas this student has satisfied? You must satisfy these requirements. So how many core areas? The student has satisfied 3 core areas. Integrative data science is one, like DS501, that's a core area. Data mining or machine learning, either of these 2 courses will satisfy the data analytics bin. Then database systems 2 will satisfy the data management core area. So by this selection, the student has satisfied 3 core areas. So what is left is 2 core areas, plus 16 credits. So how to finish your master and finish the 16 credits? So that's one scenario. So one scenario, you will spend the 5th year doing the fall and spring as follows. So in the fall, the student decided to finish the remaining core areas. And it's important to finish the core areas as early as possible. So now the student will take course in business intelligence, one in mathematical analytics. Now these 2 courses will give you 6 credits and they will finish the core areas. Now you are done with the core areas, plus 1 more elective. The typical load for graduate courses if you are just taking graduate courses, the typical load is three courses, which is 9 credits, like what you see here. So 3 courses will give you 9 credits. Then the next semester, let's say the spring semester, you will take one more elective and you will take GQB. So 9 plus 6, that will be 15 credits, right? And you are done with the GQB. GQB is one of the requirements other than the thesis that you have to finish, right? So finishing the core areas, then finishing the GQB, and counting all of these, that's 15 credits. So the student, what is remaining for the student is 1 credit. So this 1 credit can be either done as summer internship between fall and spring, or maybe over one of these two. You will do part-time internship to get 1 credit, or you can do independent study. Independent study is something that you can control how many credits you will get, 1, 2, or 3. So you can apply for independent study, maybe in over the spring semester. Now you are done with the 16 credits. Okay, so that's completing the master requirements. One question you may ask here: the 5th year looks full. It looks like 3 courses in fall and maybe 2.5 courses in spring. So that's 1 entire year. How can we finish in just 1 semester, right? So if you would like to finish early, less than 1 year, you would like to finish only by adding 1 more semester, definitely you need to plan ahead while you are undergrad student. And what you need to do is to add more courses beyond the double count. For example, if we go back, like this student took this one beyond the double count. So if you would like, or you are planning to finish early 1 extra semester, then maybe you need to add maybe 1 or 2 more courses beyond the double count. So this way, you will be able to compress the time further and maybe finish in 6 months. Okay, everyone. So that's basically the information I wanted to share with everyone. And definitely, if you have any questions later on after listening to this presentation and this information session, feel free to contact me. Feel free to contact me in using my email, or you can also stop by my office. You can get the office information from the website. Okay, thank you, everyone.